Today we're continuing this exploration into the economics of marriage, and we're going to be focusing on a particular empirical study, and I have asked CES to prepare copies of the tables that we will eventually look at. But before we look at this, I'm going to get back into some of the concepts that we ended with yesterday. And also, I'm going to be framing the problem and emphasizing some of the more interesting questions that this paper addresses. These are more practical questions. The paper is jointly authored with Catalina Amuedo Dorantes, who's also a member of my department, and at this year she's on sabbatical at PPIC, some institute in California that I'm not sure what it stands for, but it's a research institute. Okay, well, let's do the slideshow, sorry. Women's labor force participation has had very interesting history in recent years in the United States. I'd be very interested in hearing what it's like in Germany. I know overall it's been lower than in the United States, but I don't know if the development parallels that of the United States. So in the United States, there's been a huge increase in the participation rate of married women and women in general between 1965 and 1980. If you just take, for example, married women ages 25 to 29, in 1965, 33% were in the labor force, whereas by 1980, only 15 years later, 58% were in the labor force for that age group of married women. So that's an increase of 25 percentage points, and of course, a percentage increase that's much larger than that. It's close to doubling of the labor force participation. In contrast, after 1980, we don't observe a very rapid increase in labor force participation. It only grew by 11 points till 1995. Then it became 69% of all married women ages 25 to 29 in the labor force. Now, even more puzzling is that by 1995, it kind of plateaued, and recently it's even decreased slightly to 66.5% in the labor force. Now, that's a very interesting question of why this particular evolution of the labor force participation of married women, and the labor force participation for women in general, married or not, parallels the participation rate for married women, since most unmarried women are in the labor force. At least this is all United States experience. So part of the goal of this paper is to explain these trends. Now, previous studies that have looked at the changes in participation over time, of course there's been many more than just these that I'm mentioning, but I'm focusing on studies that have paid attention to the cohort factor. Because anytime you have time series, you have changes over time for people, you can possibly explain them in three ways. You can say these are period effects, so some things that happened in those times that explain what happened, the result. Or you can say it's a cohort effect. It's the people who were born at that time, that's how they behaved. And then by 1980, it's a different cohort, and they behave differently. So that's a cohort effect explanation. And you can, in this particular case, since age matters as well, you can also relate it to age. So part of the problem of the econometric side is to distinguish between the effect of year, period, cohort, which is the birth year, and the age. And one of the challenges is that ultimately you have to also deal with the fact that you have an equality by definition that the year of observation equals the birth year, which I'm also defining sometimes as cohort and sometimes as generation, plus the age. So for example, in 2007, if I take a man who's born in 1980, then of course I know that he's 27 now, assuming the month is right. Okay, so once there is this clear connection between those three variables, part of the challenge is to disentangle the effect of year from the effect of cohort and the effect of age. So the studies that are mentioned on this slide are studies that have paid attention to the cohort factor, and many other studies have not. So I mentioned yesterday a paper with David Hare that I co-authored that didn't really have much econometric analysis at all. It was very descriptive, but it already had the idea that maybe the sex ratio that is associated with various birth cohorts, maybe that explains the changes over time in labor force participation. How would that work? Well, it could possibly explain why there was the very large increase in labor force participation between 1965 and 1980. Why? Well, let's look at 1965. Okay? If we observe the year 1965 and we take women who are 20 years old, they are born in 1945. Okay? Typically, when they date, they get married or they live with someone, a man, let's say, he would be born on average in 1943. Okay? So the female in 1945, the male born in 1943. Now, what do we know? 1943 is when the United States entered World War II, right? No, when they were already in World War II, sorry. And so there were very few births in 1943 in the United States. So, and there were not that many births in 1945 either. In fact, these are 2 years of very low birth. So we have a certain sex ratio wasn't very much out of balance for the women born in 1945 if we just define the sex ratio as the difference of 2 years between the age of men and women. Now we look in 1970 and we look at again the women who are 20 years old in 1970. When are they born? In 1950. Now, between 1945 and 1950, there was a huge baby boom in the United States. It was a very dramatic increase in the number of births. And therefore, when you take, for example, which is the way we define it in this article, we look at generations as 5-year age groups. So we compare, for example, the generation born between 1941 and 1945, women in those years, men born between 1939 and 1943. Okay? And we compare them, for example, with the women born in 1946 to 1950, who would, on average, marry men born between 1944 and 1948. So what can we tell about if we just look at the numbers of birth of these men and women, of these two cohorts, these are 5-year cohorts, 5-year for the women and 5-year for the men. What can we tell? We can tell that the sex ratio for, this is, let's say, the number 1 cohort, this is the number 2 cohort, the sex ratio for women of 1 and men of 1 as well, let's call, these are men and women of cohorts 1, is going to be higher than the sex ratio for men and women born in cohort 2. The cohort, in fact, I'd like you to look at your tables and please look at table 1. Table 1 has the sex ratio using this definition, assuming that men are 2 years older than women. It tells you what the sex ratio was, and for the United States as a whole, for 11 various generations, 5-year generations, born over the course of the 20th century. And the bold numbers are for the United States as a whole. So let's go back to these 2 generations here. So I call the World War II generation. It had a sex ratio of 0.91. That was actually not, it was also quite low because the small baby boom had started in 1937 when the United States was coming out of the Big Depression. There was a growth in birth that explains why this sex ratio is also relatively low compared to the New Deal generation born between 1936 and 1940. That's a sex ratio of 0.95. And the previous generation of the Depression, 1931 to 35, they had a balanced sex ratio, 1. What happened between those generations? What happened was that there was, after the United States started coming out of the Depression, the number of births increased. Whenever the number of births increases, the sex ratio decreases because of the age difference. Because if there are more younger people, male or female, then the younger women find fewer older men to date and marry. Okay, vice versa. When the number of births declines, you're going to have higher than 1, sex ratios higher than 1. So just looking at these numbers, you can see that the very worst generation to be born a woman in the United States, the lowest sex ratio of all, is the World War II generation, the women born between 46 and 50, who on average marry men born between 44 and 48. There were 13 missing men for every 100 women for that generation. Whereas the previous generation that I singled out over here, they only had 9 missing men on 100 women. Now that makes a difference. The marriage market got much worse for women as you move from 1965 to 1970.
Right. Oh, just a question of information. I mean, this it seems like an exogenous iron law of nature that women marry men 2 or 3 years older than them. So on average, you want it to be endogenous, but I guess it's not. I mean, you can show that that's kind of...
Right. That's an assumption, of course, that the age difference at marriage doesn't change. Now, it has changed slightly over this whole period that we study. It really didn't change much, because in the beginning it was closer to 2.5 years, and by the end of the period that we study for these 11 generations, the age difference is more like 1.7, but it still averages at 2. So if we're going to take one number, the closest number to the actual age difference throughout this period is 2. And if anything, the age difference just declined over time, and you would think that if it was endogenous, it would respond differently. So, I mean, it's a very interesting study to endogenize the age difference, but at this point, we're just looking at a fixed difference. And at this point, I'm just really reproducing some of the ideas that were found in this Hare and Grossbard-Schechtman piece of 1981, which was simply looking at the numbers. We could already figure out that the sex ratios had gone down for the women who were entering labor markets and marriage markets in 1970 versus 1965, and likewise in 75 versus 70. So we, just looking at the sex ratios, we explained the very large increase in labor force participation. It was descriptive, just looking at the sex ratio and looking at the huge increase in labor force participation. Now, in this article with Clive Granger, the famous Clive Granger, published in 1998 in Population, a French journal of population, what we did is we looked at the time series and looked at aggregates of labor force participation over time as a function of cohort, not sex ratio. It just had cohort dummies. And we found that a big chunk of what has changed over time for the period, this article goes only until 1990. So we used the basic data set that you can use for this kind of study in the United States. It's called the CPS, the Current Population Surveys. And they started seriously in 1967. There are some data from before 1967. So really you can only start working with these data from 1962. And we used the period, with Clive Granger, we used the period from 65 to 90. And in the current study, we also used the Current Population Survey. But this time, we go all the way to 2005. And in both studies, yes, question?
Yeah, my question is, do you have any more disaggregate data on which kind of jobs women actually do? Because I just think that during that time there was also a lot of technological change, which offered many more white-collar jobs than before. So,
right.
Thanks.
Well, that's definitely a very good direction to go into, is to get a better sense of what changed over time in the demand for labor and in the characteristics of the workers. This is a refinement of the study that is definitely very worthwhile, but we haven't done that. So let me just proceed step by step in terms of what we've done. And at this point, I'm still surveying things that were done prior to this study. So one of the conclusions from this earlier paper with Granger is that a considerable part of the variation over time is caused by variation of the cohort's behavior. Okay. A similar conclusion was reached by John Pencavel, who also did a study of changes in labor force participation of women over time, and also found the cohort effects to be very substantial. Now, prior studies of labor force participation by Jacob Mincer and some other very important labor economists had emphasized the effect of wage and income. And we found that both Pencavel and Clive Granger and I found that cohort effects are of an importance that's really comparable to wage and income effects. Now, in the present study, we expand the data. We use individual data rather than aggregates. Now, Pencavel had also used individual data. And we use regional variation as an additional source of variation in sex ratio and labor force participation. And we analyze separately married women and unmarried women, and we work more with the education variable than previous studies. So these are all the things that we accomplished in this particular paper.
But, I mean, cohorts can't be a sort of causative variable in itself. So what do you think is causing the changes across cohorts? Is that
well, I'm coming to that. Yeah, sure. Okay. So, yeah, I think this pretty much repeats what I just said. In this paper, we argue that historical fluctuations in cohort size, due principally to the changing number of births in adjacent cohorts, caused fluctuations in sex ratio that affected marriage market conditions, and that helps explain labor force participation. So the argument now is that sex ratios are negative. The prediction is that there is a negative association between sex ratio and female labor force participation. This prediction was formulated in a more accurate way in my paper of 1984 in Economic Journal, which included, I really appreciated, I think I saw you today also. Oh yeah, that's you, right? You were sitting there yesterday. So you asked me yesterday a very good question about what about the effect of the number of men and women on the labor markets, and that would encourage, if there are a lot of women available, that would increase employment of women. Employers would be looking more for women, for example, and that could have a feedback effect on women's willingness to supply their spousal labor, their household labor. That's all very true. And the article actually addresses the general equilibrium analysis of the labor markets and the marriage markets, so that it's not so simple. Another place where you have the prediction that sex ratios and female labor force participation are negatively related is Chiappori, Fortin, and Lacroix, 2002. Now let's analyze it according to the model I presented yesterday. This model looks at individuals making a decision about how to allocate their time, whether they're married or not. If they're married or considering marriage, they would include in their utility function HI, which is the labor they are willing to supply to the spouse, HJ, which is the labor they are interested in obtaining from a spouse. And in making that decision, they take account of given Y's, YI and YJ. Now, I had a very interesting discussion after the seminar yesterday with Professor Rees, and one of the things that I want to point out in light of that discussion is that these Y's that people take into account will be different if they're not yet married than if they're actually married. Because if they're not yet married, they look at the going wages of what they can expect to get. But if they're actually married, the quasi-wage that they're actually getting or that they're actually paying to their spouse might actually diverge from the market rates. Just like when you are employed, your actual wage is different from your market value. Now, the first order condition that I discussed yesterday is right here, that in equilibrium, the individual will try to equate the value of their time in household production, but household production being defined as work done for the spouse that the spouse is willing to pay you for, and precisely is he or she is paying Y. In the case of, if we're looking at women, this is a Y that women would be getting from their husbands, and W is the wage that they get from their employer if they go to work. And if we just take married women, then of course we know they are married. This Y might be 0 or it might be positive. Most likely it's not negative. They're getting some benefits. Now, how do we interpret this? Of course, they're not getting a paycheck, but they're getting a bundle of material benefits that's comparable to benefits we get from our employers. Like the spouse may pay for the health benefits, they may pay for pension benefits, they may pay for membership in a club, all kinds of benefits that we often also get from an employer. So that's how, how you can interpret this, perhaps. One of the titles we had originally for this paper is Who Pays the Bills? Okay, basically the quasi-wage has to do with paying the bills that benefit the individual. Okay, next. To the extent that there are these sex ratio variations, that, as I showed yesterday, that will increase the relative. Was everybody here? Is there anybody here today who was not here yesterday? Okay, so you all, simple demand and supply. When the sex ratio is higher, there is relatively more men for every woman in the market, and the quasi-wage in the market, which is a component of this Y, is the component of this Y is the Y that's in the market. And if the sex ratio is higher, we expect this Y to be higher. Even if there's other components to the Y, and there's been some bargaining that has to do with some dual monopoly situation of these two people being married to each other for 20 years, obviously the quasi-wage may not be exactly the same as in the market, but they still might be influenced by the quasi-wage that they perceived as the going wage when they participated in that market at the time that they were dating or considering marriage to other people and comparing, perhaps, like most people do in a dating situation. And that's the time when we are perhaps more aware of our market value quasi-wage. And in fact, that's why when we use this sex ratios empirically, we define it when people are in their 20s. So we keep using the same sex ratio for a birth cohort, even as the woman ages, and we still include her in the data set when she's in her 40s, but we are going to use the sex ratio that women experienced when they were in their 20s as the sex ratio that helps explain, as you will see, the variation in labor supply. Okay, now let me compare briefly the prediction as it follows from my model to the prediction as it follows from Chiappori's model, since Chiappori also has this sex ratio prediction. And in step 2 of Chiappori, step 2 of Chiappori is really very similar to step 2 in my analysis. It's the step where the individual is making a decision about how to allocate her or his time. What's different is that here you have the quasi-wages, and in Chiappori you have a different concept about, so the sharing rule is the concept you find in Chiappori that will also, as is shown in the next slide, in both analyses, in both theoretical discussions, you have a situation where you have negotiations between two partners leading towards an agreement. In my model, I don't explicitly model the negotiation process. I just recognize that there's probably a negotiation process going on there, and that what I model explicitly is the market aspect of the quasi-wage. I recognize it's an element there, and that's my focus, is on explaining why this market component of the quasi-wage would change. Whereas, okay, now we get to the difference. What's different is that in the two-person models, this is where I try to incorporate some of the insights that we had yesterday, because this comparison, and maybe I should add Patricia Apps on the right-hand side, but I don't know her work enough, unfortunately. So one of the comparisons I would say about step one of the process is that in two-person models, the married households potentially pool all of their resources. We were talking yesterday in terms of an Edgeworth box, where two people are trading, and they basically, just like two nations, could potentially trade all the goods they can produce. Two people could trade all the goods they can produce. So I think in your model with Patricia, and in the model of Kepari and perhaps other models, potentially they're willing to go through the whole Edgeworth box, to all their resources. Whereas in my model, the whole concept of a labor supply or labor demand is already separating a part of the individual that is going to remain outside of the negotiation. And so in that sense, I think there is a parallel between my model and the Lundberg and Pollock model of separate spheres, which also recognizes that people are keeping some of their resources outside of the bargaining process. So I think this is a difference between the models, not really of great importance to the initial question I was raising, which is what happened in the United States between 65 and 80, and then later on. And so with your permission, I'm going to move on with the empirical study. Is that okay? Or does anybody have more questions on the theory? So basically, there's a prediction of a sex ratio effect on female participation. The sex ratio going up, quasi-wage goes up. Therefore, fewer women go to participate in the labor force because they're getting better deals in marriage. The men are more willing to pay their bills. Why go to work? If you get treated more generously, then you might drop out of the labor force or decide not to work. Okay, that's the idea. Another prediction is that there may be an interaction between the sex ratio and education. The impact of sex ratios on women's participation may be stronger for less educated workers, because less educated workers, education mostly increases productivity in the labor force. And that's really a question that we have no good data on, is to what degree does education increase productivity in household production in this context? And to what degree are men more willing to pay for a quasi-wage to educated women? To what extent is that a factor? Since we can't measure the quasi-wages, we don't know what the effect of education on quasi-wage is. But we do know that education really affects wages in the labor force, and we have lots of evidence on that. So to the extent that less educated women would be more inclined to work as housewives, then the theory would be more applicable to the less educated women. Because if we go back to the first order condition, over here, to the extent that you are more educated, you may not really want this job of, you may be focused more on this side, and you would get more benefits from being in the labor force. Getting back to the example that you raised yesterday, what about if women don't like to be home with little kids and they'd rather be interacting with adults, etc. So to the extent that education increases both the wage and the satisfaction from work, and it may not have as much of an impact on the satisfaction from household labor or the quasi-wage, then the theory would be more applicable to less educated women. Another possibility is that educated women have more egalitarian marriages, and that's another, to the extent that it's more egalitarian, that would also mean that they're less likely to get this material quasi-wage and less likely to have this the trade-off that is being discussed here. Okay. What about male education? Male education may also interact with sex ratios because it may not just be a matter of how many men are out there in the marriage market. It may also be a matter of how willing they are to pay for the household production of women, and how that would, the demand for women's household labor is not only a function of the number of men, but also of their willingness to pay, which in turn is a function of income. Okay. So marital status is also basically, the theory applies more to married women than to unmarried women, because this whole thing about quasi-wage, if women are not married, they could prepare for marriage and they may be affected by quasi-wage, but to the extent, it's okay right now?
Yeah, sure.
It's not, okay. So to the extent that they are married, they might be more influenced by this quasi-wage, especially if they're not married for such a long time, because once people are in long-term marriages, then the circumstances of the quasi-wage that fluctuates with the number of men and women may become less and less relevant. So that's one reason that when we do our empirical study, we limit our, the women in our study to ages 25 to 44. But actually, it might even be better to take away the women in their 40s and just focus on women who are even closer to marriage market circumstances. Okay, the theory of sex ratio affecting labor force participation has also been tested with cross-city comparisons. I'm going to be doing cross-cohort comparisons here, but cross-city comparisons were done in the past, again, a study of mine with a graduate student, Matthew Niederfer. He pronounces Niederfer because he's American, but his family, I think, came from Germany. So that study also showed that in the cities with higher sex ratios, you have women who are less likely to go in the labor force, and that's also a finding of Chiappori, Fortin, and Lacroix. They also use cross-city variation. However, when you have cross-city variation, you can have a spurious correlation, because it could be that the causality goes the other way. It's not necessarily that sex ratios cause labor force changes in labor force participation. Okay, the causality I am assuming is that sex ratios explain female labor force participation. But it could be that there is a spurious factor, for example, higher demand for female type jobs. Okay, that would cause migration of women to the area more than men, and it would cause low sex ratios because the women are migrating. So the fact that we observe a negative association between sex ratios and female labor force participation may not necessarily mean that sex ratio effects in the marriage markets are causing the response in female labor force participation. It could be that the causality is spurious and it has to do with the demand for the female type jobs. So when you compare cities and you can have migration across cities, that's a problem. It's more difficult to interpret. But with cohorts, you cannot migrate across the cohort. You're born at a certain time and you're stuck with it. I wished I was born at a different time. I was born during the worst cohort for women. Okay. So we already talked about fluctuations in the cohort size. That's what's causing the cohort level variation in sex ratios. And all this I explained earlier. Let's look a little bit more at the chart before we get of table 1. Let's look a little bit more at table 1 and look at the later generations, what happened over time to this sex ratio in the United States. So it reached its deepest point of 0.87, 13 missing men for the post-World War II generation. Then it started climbing to 0.95, 0.97. By the time you get to women born in what I call the Kennedy generation, between 1961 and 1965, the sex ratio has gotten to 1.03. There's 3 extra men. And for the moon generation, by the time the first man walked on the moon, the sex ratio had reached 1.06, and for the Roe versus Wade generation reaches its climax 1.07. Why is the generation of 1971 to 1975 called the Roe generation? Anybody knows? I'm sure you. Yeah, I'm sure you know, but most people don't know, right? So you also know? Okay, it's Roe versus Wade. Roe versus Wade, the abortion, Supreme Court in the United States legalizes abortion, and during that time, the number of abortions in the United States increases very substantially, dramatically. And what that causes, why is that explaining the high sex ratio? Because the women born, let's say 1971, or more accurately, the women born in 1975, okay, there's going to be fewer women born in 1975 than men born in 1973, because Roe versus Wade passes in 1973. So you have more older men born before Roe versus Wade than younger women born after Roe versus Wade. And by the next 5 years, for the first echo generation, the sex ratio has gone down substantially to a pretty balanced sex ratio of just 1 extra man. Why is the last one called first echo? Because it's the echo of the baby boom. These are most of the parents of this generation, including myself and my daughter, are baby boomers. Okay. So let's move on with the paper then. I think I covered most of this in the introduction, except that I would like to say a word for Gutentag and Seckert, who are sociologists, and I failed to mention them in the introduction. And they have a book that came out in 1983 called The Sex Ratio Question. And they also address the question of how all these things are changing with the sex ratios. They do talk about labor force participation of women, but only in a more mechanical form, that if more women are married, the total participation will be lower. So they don't address this quasi-wage thing or anything like it about married women specifically being less likely to afford to stay home if they're born at a time of low sex ratio. Another person I want to single out here is Richard Easterlin, who's a famous economic demographer, is an economist, and there's something called the Easterlin hypothesis, which is actually a bunch of hypotheses and predictions. And he also addressed the question of how cohort size has all these effects. And he even has a prediction about cohort size and labor force participation of women. But his prediction goes via 2 ways: income of the husband and number of children. He's saying if you're born in a large cohort, let's say like the baby boom, then you find your own income relatively low compared to the income of your parents, because you compare your income with your parents' income. And so therefore, if you're born in a large cohort, or you also have more competition. For these various reasons, you have less income. And so women are less likely to participate in the labor force because their husbands have less income. Furthermore, if you're born in a large cohort, you find yourself relatively poor. You don't really want to have as many children as you thought you were going to have based on what your parents did, and you have fewer children. And therefore, your wife is also more likely to go to work. So that's his explanation. His explanation is via fertility and income. Now, we're going to be able to separate our explanation from Easterlin's, even though we're also working with this size of cohort like he does, but we're going to control for fertility and income. So that will allow, if we still get a sex ratio effect after controlling for fertility and income, even though a sex ratio effect is completely created by the cohort sizes, we will be able to distinguish our results from Easterlin's. What are the other variables we include in our econometric analysis? Income and wages. Wages for women are the predicted wages. And then we have education, fertility, and a trend variable. The data we are using for the sex ratio, it's the census data. And the census is only performed every 10 years. Our generations are 5-year, and we are observing people every 5 years, so it's 5-year data. So what we do is we calculate the sex ratios for some generations when they were 20 to 24. The women were 20 to 24, the men 22 to 26. And for other generations, the women are 25 to 29 and the men are 27 to 31. So then we merge the CPS data with the census data. We estimated a variety of models, a parsimonious model that's only including endogenous variables. That means not including wage, education, and fertility. Then we include those 3 variables because they really matter a lot. And in fact, in the tables that I'm circulating here, I did not include the parsimonious model. I don't think it's so interesting. But you should know we also find negative sex ratio effects for the parsimonious model. And then we have a further model that includes the interactions between sex ratio and female education to test the second prediction. And finally, a model that includes male education as well, and the interactions between the sex ratio and the male education. So that will be at the end. We estimated our models for married women and women of all marital status. I think the more interesting results are for the married women, since most unmarried women work anyways. And we have our estimations for the US as a whole and by region. Initially, we just, in a previous version of this paper, we only had US results and we didn't distinguish the regional results. But it turns out that I'm really, frankly, surprised by the degree of variation between the regions as far as participation in the labor force of women is concerned. There's tremendous regional variation here, and the sex ratio variation by region, and in the effect of the sex ratio and the time trend, etc. So I think that the regional results are actually very important, and we're going to spend some time looking at these results. So with your permission now, we're going to look at the results together. Looking at the married regression on table 2A, that's for the United States as a whole. As you can see, there is a negative sign of sex ratio. And what does that mean? Well, to understand the meaning, since we're using probit, the best way to understand the meaning of that is to look at the marginal effects, which is the 3rd column. And what that's saying is that if there is a 10% increase in sex ratio, let's say it increases from 1 to 1.10, so instead of having a balanced sex ratio, you have 10 extra men, how would that increase labor force participation? Well, it would cause a 2% decrease in labor force participation. Okay, so it would go, let's say, from 66% to 64%. That's how I interpret this. Now, if you look at the size of that effect and you compare it to some of the other effects, the result I just gave you is for the parsimonious model. So the table 2b, which you have, you may have been puzzled here because the table you have, once there is control for all the endogenous variables, education, children, and average wages, the sex ratio effect is not as large. It's only a 0.8 change. There would only be a 0.8 decrease in participation of women for the United States as a whole, if there is a 10% increase in the sex ratio. The parsimonious model gave a much larger effect, which is not surprising because you would expect that fertility, education, and wages would all be very related to the sex ratio effect. So what else do you see in this table? You see everything else makes sense. Let me just explain what the variables are. The age factor is important. Then NLI stands for non-labor income. So this is, of course, a big factor that can also be interpreted in terms of this labor theory, but you can interpret it with any labor theory. You get the negative income effect. And then there are strong regional variations. Northeastern women and women in the West are more likely to participate in the labor force, according to this, than the women in the Midwest. The Midwest is the reference group. However, once you multiply it by the time trend, you get that all these other regions are less likely to participate in the labor force than the Midwestern women. And since these Midwestern women are going to be part of the puzzle here that we have to interpret, and this is my latest paper, so it's very recent, and I'm still thinking about all my papers, but I guess I'm busier thinking about this paper and more interested in getting your feedback because it's not published yet. So, it could be that you could help me see some more things in the data or in the theory, actually. So let me share with you what the percentage in the labor force is, because table 1 only has the changes. It doesn't have the actual percentages in the labor force for the various regions. So in 2005, which is the latest data that we are considering, this is for women ages 30 to 34, let's say, okay? Pretty representative group. In the Midwest, 74% of all women are in the labor force. Now remember, the average for this age group, 30 to 34, is for the United States as a whole is 69.4%. The 66.5% I gave you earlier is for women 25 to 29. Okay, so by the time women reach ages 30 to 34, their participation in the labor force has increased to 69.4% for the United States as a whole. However, in the Midwest, it's 74% in the labor force, whereas in the West, it's only 64.6%. So you have almost 10% difference in labor force participation for married women between the West, which has the lowest participation rates, and the Midwest, which has the highest participation rates. Now, I must say, I found that surprising. I didn't expect that there is that much variation between the regions. I don't think anyone has explained that. It's an interesting question to address. Because this is this is before controlling, but after controlling for expected wages, education, children, trend, etc., you still find that the regional variables make a big difference. And the interaction between the regional variable and the sex ratio makes a difference. So therefore, we also present regional results, and I would like to call your attention to table 3b, which is the same model, but here it's by region. And what do you see in this table? You see that for married women, in every single region, you have negative sex ratio effects. Okay? And the marginal effects are quite large for the Northeast and the West. Actually, they are the largest. The marginal effects are the largest in the Northeast. A 10% increase in sex ratio would cause a 2 percentage point decrease in labor force participation in the Northeast. We get numbers that are above 1% for every single region. So it's kind of a puzzle to me why these numbers are larger for every single region than they are for the United States as a whole. But maybe somebody can help me figure that out. But these are the numbers we get, and I think the analysis is accurate. Then we still find a very strong negative income effect. We find a time trend that's positive. And of course, the sex ratio effect, which is based on cohort, has to be compared to the time trend. Okay, let's move on to what's the conclusions and the findings that are on this slide. Can the negative association between labor force participation and sex ratio be interpreted according to an economic model of marriage-related decision-making, such as Chiappori and Grossbard-Shechtman? For the US as a whole, the sex ratio variation includes, oh, that's the thing, that when you look at the sex ratio effect for the United States as a whole, you're including variation in sex ratio across the regions as well. So apparently, there's something going on with the sex ratio variation across the region that weakens the overall effect for the United States. That's probably why for every single region separately, we have stronger effects than for the United States as a whole, even though we're controlling for the region. So it may have something to do with this reverse causality thing of regional variations also including differences in demand for labor, etc. So it could be that if we did control for demand for labor by region, we would get stronger effects possibly of sex ratio. If women are of any marital status, there are also sex ratio effects on labor force participation, but we think that these basically amount to sex ratio effects by marital status. The next table, 3C, is a table that includes the interaction term between education and sex ratio. Now, the sex ratio here was not calculated separately by educational group. It would probably improve the paper substantially, the results substantially, if we had sex ratios calculated by educational group. We don't. Nevertheless, we do find that in some of the regions, our prediction is confirmed. And actually, that is only one region for the married women where it's confirmed. That's the West. In the West, you find a negative sex ratio effect, and you find that it's not as strong for educated women. So once you include the interaction with education, you get a positive sign. However, in the Midwest, it's the opposite. We get that in the Midwest, the sex ratio effect is positive for women with low education, but once you include the interaction term of education and sex ratio, then you get negative effects of sex ratio. So somehow the theory for the Midwestern women works better if they're educated than if they're less educated, whereas the prediction was that was not, the opposite was going to be the case. And so the prediction works for the West, it doesn't work for the Midwest. To me, that's a real puzzle. I would like to understand better what are the differences between the West and the Midwest that cause these different results. What about the South and the Northeast? The South, we find no sex ratio effect anymore once we include this interaction. But remember, in the previous table, all the sex ratios effects were negative, so somehow this interaction takes away from the sex ratio effect altogether. In the Northeast, we still get the negative sex ratio effect, but no effect of the interaction. So the next table, 4, has the United States as a whole again, and this time it includes the, no, you can have it. I know what's to be, I may not be, may not be so practical over there if I'm moving. So in table 4, we have male education included as well. So that gives us a chance to see whether if it's just the numbers of men and women, or if it's also the education of the men which increases their earning power. And we do find that once you have this smorgasbord of all these variables included with all their interaction term by region, you do still find a sex ratio effect, but overall for the United States now the simple sex ratio effect is positive. However, when you interact it by female education, it's negative, it's a negative sign. And also, at this level, we see no effect of male education. However, if we do a similar exercise by region, which is in table 5, we have the 4 regions separately. This is just married women because we have their husband's education. What you see here is that, again, the Midwest gives us the positive sex ratio effect, but the negative effect of female education. There is no male education effect that's adding to the female education. For the West, we still find the results that follow both predictions of the theory. Now, in the South and the Northeast, we find a negative effect of the interaction of sex ratio and male education. So here we find, for the regions that previously didn't show us any interaction terms, now we find that actually it seems to be the case that in order to find a negative sex ratio effect, you have to take account not just of the number of men, but also of their earning power as measured by wages. So these are the results of this study, and I'd like to conclude on a number of levels. First of all, there's a relatively practical conclusion, and that is that our study has helped us understand the pattern that was described in the beginning, with rapid increase of labor force participation in the 60s and 70s, slow participation in the 80s, and then by 95, a slight drop in the labor force participation. Why? Because the women we're studying were overwhelmingly baby boomers in the first part of this historical period. So the baby boom women had low sex ratios, they had to go to work more. Then you find that the sex ratio gradually increases, and we find a slowdown in the increase in the labor force participation of women. And by the end of this period, we have those generations that I call the moon generation and the road generation, characterized by very high sex ratios, and they are able to, the women of these generations apparently, according to this, these findings, I think we can interpret this as saying that women have been using their market power out in the marriage markets to bargain with their husband into situations where they're less likely to go to work. And so that's how I interpret these findings. Yes?
The initial increase in labor force participation was about 25 percentage points.
Right.
The one you mentioned earlier.
Right.
But then the actual coefficients point to that the impact of sex ratios would be at most, say, 2 or 3 percentage points.
Right.
So maybe...
Well, obviously, there's a lot else going on. There's a time trend that's very important. So if you look at the estimates of the time trend, for example, in table 2b, the marginal effect of the time trend for the United States as a whole was 0.006. So, you know, it's not very large, but for some, yeah, that could be part of it. There's the increase in, well, yeah. So it's positive, though. There's many other factors that are accounting for the changes. A big factor is the number of children, because we see that that's a very strong variable, the number of young children. There was a big decrease in fertility over this period as well. So, yes, this is only a partial explanation. Obviously, I may be exaggerating the magnitude of the finding. I appreciate your point.
If you add up the implications of the Easterlin hypothesis,
right,
how large they are as compared to the sex ratio.
Okay, well, I would say that the results show that even after you include fertility and non-labor income, which are the variables that the Easterlin hypothesis works with, you still find a sex ratio effect that goes according to the theory, as long as you don't include the interaction with education. And after you include the interaction of education, you get the negative sex ratio, sometimes for less educated women and sometimes for more educated women. I think, first of all, Easterlin only has an explanation that goes by fertility and education, and income, I mean. And second of all, you would have no story for these interactions with education. So, and likewise, I don't know if Chiappori has a story for the interaction with education. Directions for further work. It would be very interesting to get international comparisons. I also gave this paper in Sweden at the Sophie Institute, and Sweden is a very interesting case because they had their baby boom in the 40s and not in the 50s. They had their baby boom earlier than the United States and most other countries. So it would be very interesting to see if there are different patterns in labor force participation as a result of that. It would be interesting to calculate different sex ratio variables, and there's many possibilities, including a measure that was developed by demographers Noreen Goldman and two other people. And they have a very refined sex ratio variable that takes account of all the possible age differences and weights them with the number of people who had that experience that age difference. So potentially this can be done as well. And so that would be more accurate than just using this 2-year age difference that to some degree drives the results. I would like to conclude with just one last point about that takes more of a theoretical perspective, to the extent that this is evidence for sex ratio effects on labor force participation. I just want to point out one more direction that this kind of theory can lead to, and that opens a lot of very interesting possibilities for empirical research. And that's the hypothesis that there will be compensating differentials in marriage markets, and that these compensating differentials could cause variation in female labor force participation and perhaps also male labor force participation. What's the idea here? You're all familiar, I imagine, with the idea of compensating differentials in the labor market. It's the idea that if you take, let's say, a construction job that's seasonal and you might experience more unemployment, they will typically pay you more than a similar job that requires similar skills, but it's not as risky. So the more you undergo the risk of unemployment, the more you're likely to get compensated financially for the risk you're taking as a worker. Well, the same idea applies to marriage. If you marry a person who's from a less desirable group, you're taking more risks, maybe it's a higher probability you wouldn't get along with this person, you may want a compensating differential. So also in a society that has racism, the people from the groups that are racially discriminated, they might have to pay compensating differentials. So in the United States, for example, where there's much evidence of racism against black people, one of the implications of this would be that a black man would have to pay more to a white woman in terms of a quasi-wage in the form of material benefits versus a white man of comparable attractiveness. So that's something that's testable, okay? And it's something that is not typically included in labor supply studies. So it's something that I've tested in an article. It's my only JPE article that was published with a colleague in Israel, Shoshana Neumann. It was published in 1988. And we used Israeli data where there's also discrimination against people. There was just Jews in this particular study. And we were talking about discrimination against Jews from Asia and Africa versus Jews from Europe and America. And we did find that if an European Jewish woman marries a man who is from Asia and Africa, and presumably she would require a higher quasi-wage in material form when she marries him, well, it was associated with lower participation in the labor force. And in another study that I've done along these lines, in cooperation with Xuaning Fu, who's a sociologist, we used Hawaiian data from the United States. And in Hawaii, it's a very ethnically varied society. There's lots of Japanese and Hawaiians and, of course, Caucasians. And again, we assumed that there was discrimination in that case against Hawaiians. There were not that many blacks and Hispanics in our sample. We did find the same result. We did find that the Hawaiian men had to apparently pay a compensating differential when they married Caucasian women, but not vice versa. So when Caucasian men married Hawaiian women, we didn't find evidence of a compensating differential, which follows pretty much from the theory that since most of the time men pay quasi-wages to women much more so than vice versa, it's the Hawaiians being discriminated against in Hawaii. Unfortunately, but that's always unfortunate when there is discrimination, but that's what appears to be the case from other studies. We can tell that Hawaiians are typically discriminated against, and so we did find that the men who are discriminated against apparently have to pay compensating differentials in that form of quasi-wage, which we don't observe. We don't observe the quasi-wage, but we can observe circumstances that can be associated with higher or lower quasi-wages, such as sex ratio variations, which would lead to fluctuations in the quasi-wage, or compensating differentials among different groups. Do you have any questions?
Can I ask a question that's actually referred to in one of the paragraphs there? Your dependent variable is sort of participation, which is a kind of 0-1 variable. And it's actually not necessarily a very good indicator of labour supply, right? So, for example, in Germany, the participation ratio is actually not that far below the US or whatever. And yet, female labour supply is much lower because there's much more part-time working and so on. Do you have any sense of whether that's a very relevant consideration for your results?
Definitely. I think that the degree of labor force attachment is a very interesting variable as opposed to the labor force participation. And by the way, in all these analyses were about any participation, part-time or full-time. And actually, the rate of participation of women in the United States, if you exclude all the part-time workers, is not that high. It's much substantially lower. It's closer to 50%. And I have experimented with some empirical studies of labor force attachment, which would be full-time work year-round. And so far, I haven't found that sex ratio affects the attachment as much as the labor force participation. But potentially, it would definitely be a good direction to go to look at the various measures of labor supply and to, first of all, infer theoretically where do we expect more impact and why, and then do the empirical studies. I think this is a very good example of labor economics and household economics needing more theory, because you can try millions of regressions, but what do they mean exactly? So I think there's a need for exploring that more at the theoretical level as well. But I'm sure it matters.
And in your regressions, did you have the sort of husband's wage as one of the independent variables when you're looking at participation?
Well, non-labor income in this case includes the earnings of the husband.
Okay.
So it's not just his wage, but his earnings, which is, of course, somewhat of a problem because his hours of work are included as exogenous here.
I mean, how does, I mean, I think at least in recent years, most of the marriages did not last for the whole lifetime anymore. How do these fluctuations enter the whole story, and is there maybe effect on sex ratio on number of divorces or anything like that?
Well, excellent question. I think that the divorce rate and the divorce probability are definitely a part of the decision making here, especially if you are thinking in terms of these quasi wages, etc. So, you know, if we conceiving of women as making a choice between two careers, then it's not what and it's a one-period model, really. It's not a dynamic model. So, still, ideally, we would want to take account of the expected job stability of both the employment career in the labor market and the marriage career in the marriage market. So the expected stability of these forms of income, potential income for the women would be definitely important here. And there's plenty of studies that have already indicated that there is an association between divorce and labor force participation of women in the direction that's expected. There's one of the classical articles on this subject is Johnson and Skinner, American Economic Review 1986, which is not about time series, but it's about a panel study where they look simultaneously at the effect of divorce on labor force participation and labor force participation on divorce. And I'm pretty sure they find that divorce affects labor force participation. But I remember that one of these effects was stronger than the other. So it's definitely another thing that's worthwhile exploring and that has not been sufficiently used in explaining these kinds of questions. Generally, in recent years, there hasn't been a lot of literature on estimating labor force participation of women. I mean, you were doing a paper yesterday. Did you find a lot of literature on that?
Well, like the whole grade we have to do our empirical class from Professor Winter, and but we didn't find that much, I think, so far, yeah.
Yeah, we
So-
just have data from
Yeah.
1975, so we don't see any evolution, obviously.
Right. So that's because there haven't been a lot of recent studies on this. Pencavel is one of the recent, relatively recent articles, 1998, that's often cited. So it's a field that saw a lot of articles for a while, and then people just moved on to other fields, which often happens. And there's a lot more questions to deal with that we address to some degree in this paper, but obviously there's a lot more that needs to be explained. Yes?
Would you have any sense how the age of the woman at her first marriage would impact the labor force participation? It's somewhat related to Joachim's questions, because, well, obviously, if marriages become less costly to dissolve, divorce rates go up, then people, well, if you're single, it's basically an optimal step in the process, right? Then the option value to waiting till you get married should go down. So
It's an excellent idea. It's something that's relatively easy to do. We wouldn't be able to do that at the individual level because the CPS data that we use don't include age at marriage. They're not they ask relatively few questions. It's a relatively short questionnaire. I don't think we have that information for the CPS data that we use, but we could use the age at marriage of each cohort, not just their sex ratio, but also their age at marriage. I think that's an excellent idea. That's something that we could calculate for the cohorts, because it would matter, yes. It's a very good point. Well, I think we are done, right? Mm-hmm. So next week, let me just give you a little bit of a preview of what I'm going to do next Monday. It's going to be a different direction. We're going to be talking about law and economics of marriage. So we're not going to be talking about labor force participation. We will be talking about marriage and divorce laws, and particularly the empirical study will be about their impact on birth without a partner. So that's what we'll do next week. Thank you, and see you next week.